Alright, section 3 deals with the surface area of pyramids and cones. So, like pyramids like in Egypt or, the Aztec pyramids down in Mexico type of thing. That's what we're going to be looking at. And then cones like ice cream cones and traffic cones and any other type of cones you can think of. Cones of silence and cones of thinking. Yeah. Anyway, that's what we're going to be looking at. We're going to be looking at the surface area of these. So as you see, a cone and a pyramid are similar, but they're different from prisms and cylinders because they only have one base and they meet at a single point. And so that's what we're going to be looking at and how it's a little bit different. And so a pyramid is a polyhedron with one base and triangles that meet at a common vertex, okay, which is kind of what a pyramid is. And a regular pyramid has a regular base on the bottom. And what we're going to be usually dealing with is objects that are regular or pretty simple at the bottom as the base. We're not going to be throwing some wacky, dacky polyhedron at you, or polynomial or polygon at you. That's going to be like really difficult to figure out what the area is. It's going to be pretty straightforward and you're going to be able to find it. Now, we're going to throw in a new word here. It's called the slant height or the slant length. Okay. And so what this is this is the height of the triangles that are moving up the sides of the pyramids and the cones. Okay. So it's the length going up from the base up to the top if you were to walk it. And the height of it is the altitude of it. So from the middle point straight down. Okay. As you can tell, you can't walk that height. You can't do that because that's in the middle of the object. But you could walk up the side of it. And that's what the slant height is. And it's from the mid segment or from the midpoint of that bottom base. Okay. All right. Now the lateral area of a pyramid. The lateral area of a pyramid is 1/2 times the perimeter times L. And what L is it's this lateral height or lateral length. Okay. So that's what L is. So wherever you see this L, that's the lateral height. So that's the length going up from the base of the pyramid up to the top along the side of it. Okay, and that's your lateral. So you need to find the lateral height sometimes if you're given the altitude. Sometimes you have to find the height when you're given the lateral height. And we'll talk about that exactly. All right, so in this example, we want to find the lateral area, so the area of the triangles, that is equal to 1/2 PL. And so we got 16 as our lateral height, 10 as our base for this each side of this square, which is what we're kind of dealing with here. And as you see here, this kind of is using the area of the triangle. So we're trying to find this area of the triangle and multiply it by the number of sides there are. So it looks like it's going to be about 1/2 times the perimeter, which would be 10 times 4, multiplied by 16. And multiply it all together, and we get our answer of about 320 meters squared. So again, we're talking about area, so we got to go meters squared in this case. Okay, so 1/2, 10 times 4 times 16. Okay, pretty simple, pretty straightforward. Okay, now the surface area. The surface area of a pyramid is the lateral area, again, plus only one of the bases. So if you remember for prisms and prisms and cylinders, what we did was we multiplied by two bases. Well, since a pyramid only has one base, we only have to multiply it by one base, or add in one base. So it's LA plus B. So SA equals LAB, or SA is equal to lab. And so if you don't want to use the LA, it'd be 1/2 PL plus B. Whatever the area of the base, that's what this capital B is. It's the area of the base. Has to be. Okay. All right, so now let's do a little kind of a trickier one here. So we've got a pyramid with a pentagon base. Okay, so we've got a pentagonal pyramid. And each base of the triangle is 7 inches, which means each side of the pentagon is 7 inches. And the altitude is 10. What is the surface area? Well, if you remember the surface area, we need something called the slant height. Well, the slant height and the surface area are different. Or slant height or lateral height and the altitude are different. And so what we have to do here is that we have to find what's called the apothem. Okay. And you have to find it anyway because you need the area of this figure. So you're going to be using your trig to help you find this length right here. Now once you know this length, which I'm going to identify it's purple right now. Now if you look back at the original shape and we look at it from kind of a side point of view, okay, what we have here is that here's our height or altitude of 10. We want to find this length right here. That's what we have to find. That's our L. And what we have is that we've created a right triangle where our apothem will be right there. So this is kind of a multi-step problem. First, you have to find the area of the base using the apothem. Now, once you know the area of the base and the apothem, which each side here is 7, 7, 7, 7, 7. Once you know that, okay, you're able to find the lateral height by plugging into this and then using the formula of the altitude squared plus the apothem squared is equal to the lateral height squared, okay, or by using the Pythagorean theorem. So altitude squared plus apothem squared is equal to the lateral area squared, or lateral height squared, okay. Or if you don't want to use altitude, you can say h. So h squared plus a squared is equal to l squared. Now once you do that and you plug it all in, you end up getting your answer of about 278.6 inches squared once you plug everything in, finding your apothem, finding your area, and add it all together. Okay. Your lateral area. Now your lateral area for a cone, remember a cone has a circle for a base. So our lateral area of a cone will be 1/2 times the perimeter of the cone, which is the circumference, pi r squared, or 2 pi r, and then multiplied by the lateral height, again, L. And then if we just simplify this equation, we end up getting our formula of LA is equal to pi r L. Okay, and that's what it would be. Okay, so that's your lateral area. So if we have our lateral area here, as you see, they give us our L, which is 20. And they give us our height, but they don't give us our R. We have to find what R is. Well, we've got another right triangle here. So it looks like it's going to be 20 squared is equal to 15 squared plus R squared. And so then you would plug in, plug. And we ended up getting our, and then after we do that, we multiply it all the way through, and we get our answer of about 264.58 pi. Centimeters. So this will get us our R, and then we plug the R in there, and then we multiply by pi, etc., etc. Okay, and we want to keep it in terms of pi. It doesn't give us as messy as decimals, but this one it kind of did. Okay, so now surface area. Surface area for a cone, similar to the surface area of a pyramid. You take the lateral area and add it by the area of the base, which the area of a cone for the base is a circle, pi r squared. And so that's all it is. You just add pi r squared to it. So if we look at this, what we're going to have to do is we're going to have to find what the slant height is here. So it looks like it's going to be 6 squared plus 49 squared, or 7 squared, which is 49 plus 36, which looks like it's about 85. So the square root of 85 is that height. And then we would multiply it all together. Get your decimal, add them together. This is your R, so that goes there and there. This is your L, that goes there. You don't need the height. And when you multiply it and add it all together, you end up getting about 9.32 pi meters squared. Again, meters squared area. Your IRAT, find the lateral area of the square base pyramid, which each base is 5 and the slant height is, or each base side is 8, slant height is 5. And find the surface area of a cone with a radius of 12 and a height, which is the same as the altitude, of 5. So you have to find the L in this problem. Okay.